Artificial intelligence is becoming increasingly popular nowadays. The purpose of this video is to explain the general concept of AI, and more specifically, its subset known as machine learning. This video is aimed at non-technical individuals and beginners in the field. AI is often used to solve problems where it's difficult to define exactly how something works. In traditional programming, you need to understand each step of the entire process. For example, if you want to create a program to calculate the average student mark from a list of marks, it's straightforward. You can sum up all the values and divide by the total number of marks. In this example, you know what needs to be done with the data to get the correct result. However, there are problems where determining the solution isn't as straightforward. For instance, consider the task of automatically counting the number of humans in an image. Counting itself is simple, but deciding what should be counted is much harder. Every person is different poses, clothing, faces, etc., and the algorithm needs to be precise. Creating a traditional algorithm for this may not be impossible, but it is very challenging. For these reasons, the concept of artificial intelligence was introduced many years ago. AI refers to the simulation of human intelligence in machines that are programmed to perform tasks requiring human-like cognitive functions. In traditional algorithms, as I mentioned earlier, you need to define the rules explicitly. In AI, however, the rules are learned during a training process, similar to how the human brain learns. There are three main types of learning: supervised, unsupervised, and reinforcement learning. Supervised learning is the most common. It requires a dataset with labeled examples. Referring back to the example of counting humans in an image, training an AI for this task would require many photos with labeled humans in various situations, different lighting, locations, ages, etc. The more diverse your data, the more versatile your AI model will be. However, everything depends on the specific task. For example, if you only want to detect children, you don't need photos of 80-year-olds. A model based on the provided data will generalize by identifying specific patterns. If your dataset is of good quality, the learned patterns should work well even with unseen data. The way the model learns these patterns depends on the chosen method. There are many methods, such as neural networks or decision trees. Generally, most of these methods adjust specific parameters for the chosen approach by comparing the results of inputs from the dataset with their labeled responses and then making changes to reduce errors. Unsupervised learning, on the other hand, does not require labeled data. The model tries to find similarities, patterns, or structures within the dataset. While harder to use, it can be beneficial in certain scenarios. For instance, if you have points of two different colors and want to group them by color, unsupervised learning can help. Reinforcement learning is based on a reward system, aiming to maximize it by finding the optimal sequence of actions that lead to the highest cumulative reward. It is commonly used to create game bots. For example, imagine creating a program for a tic-tac-toe game. First, the rules of the game need to be defined. Then, a reward value increases for each move that leads to a win and decreases for moves that lead to a loss. The program can then play against a human or even itself, gradually improving its performance with each iteration. This is how it basically works. The better your data, the better the results you can achieve. Combine this with years of advancements in algorithms and computing power, and we now have tools like those you've seen recently. An AI model still uses programming code, but the code is designed to enable learning from data rather than solving a specific problem directly. This is why the same model, when trained on different datasets, can be used for entirely different purposes. Most tools using AI operate not only on the AI model, but also integrate traditional algorithms. These algorithms use the trained model at specific steps to perform certain tasks and then process the results further. Sometimes, multiple models are used together to achieve more complex goals. For example, one model may generate multiple responses, and another model selects the best one to return to the user. You can train a model to do almost anything if you have the right data. However, data availability is the biggest challenge. Sometimes there are issues with how data is represented. Computers work with numbers, so data must be represented in a way that the computer can understand. For instance, when creating a chatbot, the data must first be pre-processed. Almost anything can be represented as a number if done cleverly. For example, you can assign numbers to words, perform operations on them, and then convert them back to text. In modern models, it's more complex than simply assigning a number to a word, but the concept is similar. This process is called tokenization. The results may include whole words, parts of words, or even single characters. Simplified, you can think of it as dividing text into syllables and creating sequences based on that. On the other hand, image generation models process images as arrays of pixels, where each pixel's color is represented by a number in a specific format, such as RGB or HSV. Similarly, music can be represented as a spectrogram, which shows how the frequency of sound changes over time. The pre-processing steps depend on the problem being solved. For the computer, it doesn't matter what the dataset represents, as long as it's properly formatted. You can train a model to detect a specific disease based on blood test results or to find patterns in randomly generated numbers. If the dataset's input corresponds to the desired output, the model can learn it. This is why machine learning is so powerful, but it also has its limitations. Currently, one of the biggest challenges is that models must be trained for specific tasks. For example, if you want to classify animals in images, you need to train a model for that purpose. If you want to detect humans, you have to train it again for that specific task. One trained model can solve only one specific task. There is no such thing as AGI, artificial general intelligence. Another problem with many learning methods is explaining exactly what the model has learned. For example, when you train a model using deep learning or neural networks, it may learn how something works, but you can't simply check and say, okay, it works like this, so now we know the formula for this problem. No, you provide an input, receive the correct output, but how it achieves that result remains unknown. It's essentially a collection of weighted numbers organized in a specific structure. Through many simple operations like summing, produce the correct answer. But these problems are being actively researched, and AI models are continuously improving, so perhaps they will be completely solved in the near future. It's important to use AI models where they truly make sense. Nowadays, almost every product claims to have AI features for marketing purposes, but in some cases, it's not necessary. AI is a vast field, making it impossible to cover everything in a single video, but I hope you've understood the basic concept. AI is truly worth your attention.